Okay. So last time we are able to cover yung anong topic yun? Yung empirical formula, percent composition, tapos yung obtaining empirical formula from percent composition. No? So nandiyan naman sa group chat natin yung answers. No? So anyway, so punta na tayo sa next part ng chapter na ito. No? So the next part of this chapter is about balancing chemical equations. No? Pero bago tayo mag-start dyan, alamin muna natin bakit kailangan ng chemical equations, no? So, review muna tayo ng Gen Chem uli, no? So, we know that our matter can undergo two types of changes. So, we can either have physical changes or chemical changes, no? So, what's the difference between the two? Is that for physical change, ang nagbabago lang ay yung physical appearance ng matter, yung kanyang state of matter. So one example is melting of ice to liquid water, no? So we can represent that with an equation H2O solid that is transforming to liquid water, no? So kumbaga, you still have the same chemical formulas. However, yung state of matter yung nagbabago. So dito solid indicated by a small letter S. And dito, liquid na siya after the physical change. No? So, yan yung isang type ng change na pwede idaanan ng matter natin. The next one would be chemical changes. No? So, ano yung chemical changes? Ay, hi Mary. Nag-start na ako. So, anyway. So, kapag may chemical change naman tayo, ano yung difference niya sa physical changes? Sa physical changes, yung appearance yung nagpapalit. Sa chemical changes, yung chemical identity yung nagbabago. No? So, kunwari, kung ano yung reactant mo, hindi na siya yung sa product mo. No? So, for example, if you combust sugar, kunwari, kasya ba dito? C6H12O6. Okay lang. Ano ito? 12. Okay, so kunwari ito. So suppose we have the combustion of sugar producing carbon dioxide and water, no? So this is a chemical change. Paano natin nasabi? One reason is that nagbago yung kanilang chemical identity. No? When you say chemical identity, we are pertaining to the chemical formula. No? So whenever nagbabago yung ating chemical identity or chemical formula, we have chemical changes. So nagbabago yung kanyang appearance or yung anyo ng matter natin. So for example, we have here glucose sa reactant. After the reaction, ano yung nangyari? We have CO2 and H2O na lang. So wala ka ng glucose dito. Carbon dioxide and water na lang yung nasa product mo. So that means for chemical changes, the chemical identity of your reactant changes. No? So nagbabago yung kanilang chemical equations. No? So, yan. So, ito yung dalawang uri ng changes na yung matter natin ay pwede mag-undergo. So, physical changes, change ng state of matter. Chemical changes, change sa chemical identity. So, kung ano yung reactant mo, hindi na siya yung sa product. No? So, magkaibang substances na sila. Usually, we accompany our chemical changes with chemical equations. No? Equations dapat to. So yun, yung chemical reactions natin or physical changes, no? Pwede rin yun. They are usually accompanied with chemical equations. So example sa baba, this is a chemical equation. So makita nyo on your left side, you have your reactants. On the right side, you have your products, no? The two are separated with a reaction arrow, no? So andito yung mga definition nila, no? So read nyo na lang. So anyway, so ito yung reactants. These are the substances that we react with, no? So sila yung mga pinaghahalo-halo natin. Sila yung pinapag-combust natin, so on and so forth, no? Para ma-produce yung product, no? So yan. So on the left side, you have your reactant, right side you have your product, and in the middle you have your reaction arrow. So ano yung reaction arrow naman? So the arrow tells us to which direction the reaction will proceed. Usually, that's one-way arrow. So, arrow to the right side lang yon. Usually, going to the product, no? However, there is a certain type of arrow na tinatawag naming equilibrium arrow. So, ano mapapansin nyo sa equilibrium arrow? That's a two-headed arrow as compared to the single-headed arrow pointing to the right. No? So the equilibrium arrow has two directions. It could either go to the right side or pupunta sa product side, or the reaction can go to the reactant side. So kumbaga may dynamic reaction na nangyayari. So when we say dynamic reaction, two-way yung reaction. May papunta sa right, may papunta sa left, no? May papunta sa product side and may papunta sa reactant side, no? Okay, so it doesn't matter masyado for now kung anong arrow yun nandyan, no? So pwede tayong maggamit ng single-headed arrow pointing to the right only, or we can also use equilibrium arrow, no? Yung double-headed arrow. Okay, so yun lang. And in our reactants and the product side, we have our formulas. So what are chemical formulas? These are formula representation. Sila yung nagre-represent ng number of atoms in a molecule. No? So sila yung mga molecular formula natin. So they tell us kung ilang carbon meron, kung ilang hydrogen meron, no? Kung ilang oxygen atoms meron. Yun. So yun yung chemical formula natin. They tell us kung ilang atoms yung meron, ano-ano yung mga atoms na meron sa isang molecule. And chemical formulas are usually accompanied with subscripts, no? Sila yung mga small numbers, no? Yung mga subscript. So, ano yung kwento ng subscript? That tells you kung ilang atom meron ka. For example, here we have C3. So, ibig sabihin nun, may 3 kang carbon. H8. So, ibig sabihin nun, may 8 kang hydrogen. O, don't confuse the subscripts with the coefficient. Yung coefficient, hindi siya yung nasa baba kasi nasa baba ay subscript. Ang coefficients or stoichiometric coefficient, they are written on the left side of the equation. So ito yung equation mo, nandito siya sa left side. That tells you how many of that molecule you have. No? Kunwari, we have 5 O2. That means you have 5 oxygen molecule. Or in total, you have 10 oxygen atoms. No? Kasi in this formula, we have 2 oxygen atoms in one formula. Etong 5 na to, that serves as our multiplier. So, bali, that's 5 times the number of atoms here. No? So, for example, ito, ilang carbon meron tayo dito? So, we have 1 carbon in our formula times 3 as indicated by the coefficient. So, you have 3 times 1, 6 carbon. 3 carbons. O, ilang oxygen naman meron dito? So you have 2 oxygen atoms in this formula times 3. So that means you have 6 oxygen atoms here. No? So 3 carbon atoms, 6 oxygen atoms for this part. No? Ganon din dito. No? So yun. So kumbaga, ang purpose ng coefficients is to serve as our multiplier. No? Para saan, no? Kasi later on, we will balance the equations, no? Tapos mamaya, alamin natin yung mga rules when balancing chemical formulas. No? Teka lang. Okay, so anyway. So yun lang, no? So yun yung mga parts of a chemical equation. Don't confuse stoichiometric coefficient with subscripts, no? So magkakaiba yun. Yung subscript that is innate sa formula, meaning nandun na yun sa formula, no? So fix yan. Kasi kapag binago mo yung subscript, that means you are pertaining to a different formula. No? So, ibig sabihin nun, ibang formula na yung pinapatukuyan mo. That's why the subscripts are fixed. No? So, hindi mo sila pwede galawin. Ano lang pwede galawin? Yung coefficients, no? The multipliers. No? So, ganun lang ha. So, wag nyo babaguhin yung subscripts. Only the coefficients. No? So, yun lang. So, punta naman tayo dito sa next part, no? Why do we have to balance equation, no? Ano ba yung importansya niyan, no? Number one is that remember that chemical equations or chemical reactions undergo, uh, follows the concept of the law of conservation of mass, no? Sabi yun ni John Dalton dati, di ba? Sa kanyang atomic theory. So, sabi ni John Dalton na in every chemical reactions, no, conserved ang amount of matter. So, kung gaano karaming atom mo on the left side, on the reactant side, that must be true for the product side, no? So, yun yung idea ni John Dalton about the conservation of mass. So, that means kung ilang atoms meron ka on the reactant side, dapat ganun din yung atoms mo sa product side. Nothing more, nothing less. So, kailangan equal sila. That's why we have to balance the chemical equations. No? So, how do we balance chemical equations ba? No? So, yung formula, hindi natin pwede yun, baguhin. Hindi natin pwede baguhin yung subscripts, no? Kasi whenever we change the subscripts, we are pertaining to a different compound, no? Which is hindi yung gusto natin. Ang gusto natin baguhin kapag tayo ay nagbabalance ng chemical equation ay yung mga coefficients, no? Yung number sa left side ng formula. So we add the we add the coefficients. Ano yung purpose ng mga yan? Para maging multipliers sila sa dami ng atoms, no? So, ganun yung gagawin natin whenever we are balancing equations. We do not alter the subscripts, rather, we add coefficients, no? So, we add coefficients in order for the number of atoms to be equal, no? So, alam ko medyo struggle to sa karamihan sa atin, no? Kasi maski ako minsan, nahihirapan din ako mag-balance, no? Although, may techniques akong i-share sa inyo, no? Para mas madali mag-balance ng equation. So anyway, so the generic steps are as follows, no? So 5 generic steps 'yan. Bibigyan natin 'yan ng in-depth view mamaya, no? Kasi may bibigay ako ng shortcuts sa inyo kung paano mag-balance ng equation. Kasi 'di ba ginagawa natin dati nung high school tayo, iniisa-isa talaga natin yung atoms, di ba? Ngayon, may proper way, no? So, turo ko yung proper way, no? Pero anyway, ito muna tayo. Ano yung general steps? Number 1, identify the reactant, the product with their correct formula. So, you should be able to know kung ano yung mga chemical formulas na. Kailangan alam nyo na kung ano yung tamang formula. So, kung hindi criss-cross yan, edi yung mga binary molecules, no? Yung mga naming ng covalent compounds, no? So, kailangan familiar na kayo doon. Then, count the number of atoms present on each side, no, of the reaction, left and right, no, the reactant and the product. Then, you balance the atoms or the element that exists only once in a chemical formula. If you have polyatomic ions, balance them first and add coefficients until the number of atoms balances. Kumbaga, ito yung generic type, no? So, punta na tayo sa mismong ideas, no? So, mamaya magbibigay na ako ng tips, no? So, let's begin with this one, this equation. So, what we have here is that carbon reacts with oxygen gas. Pag oxygen gas, ang formula nun ay O2, no? So, yan talaga yung formula niya, O2. So, carbon reacts with oxygen gas to produce carbon monoxide. CO, no? So, kailangan alam niyo yung mga formula out of the names and vice versa, no? So, gagawin natin, we check first if the equation is balanced, no? Is this balanced? No? Gawa tayo ng table. So, here you have the reactant and the products, no? So, bilangin mo kung ilang carbon merong dito. Meron kang isa lang. On the product side, you only have 1. Okay? Sa oxygen naman, you have 2 oxygen atoms here, indicated by the subscript. Tapos, you have 1 oxygen atom here sa product side. No? As you can see, the carbons are balanced. However, the oxygen atoms, hindi. No? So, anong gagawin natin? So, we can balance them. No? Usually, ang ginagawa natin dati, kapag may odd number, ginagawa nating even number yon, no? Okay, so for example, the carbons, odd number sila. So, sila yung pwedeng gawing even muna, no? So, we multiply this odd number with a number para maging even sila, no? So, we try to multiply this, this formula, the carbon monoxide by 2. Bakit kailangan i-multiply sa 2 yung carbon monoxide, no? Kasi we have odd number for the oxygen here. 2 yun sa reactant, isa dito. So, i-balance natin yun, no? So, by multiplying the formula ng CO by 2, magiging dalawa na yung oxygen atom doon, no? So, yan. However, as a consequence, yung carbon, naging times 2 din, no? Kasi distributive yung property ng coefficient. That means, yung number 2 na yan, mo i-multiply yan kay carbon, pwede mo rin i-multiply kay oxygen, no? So, we have 2 oxygen atoms here, 2 carbon atoms here, no? So, nag-even na yung numbers natin. Oh, look at carbon naman on the reactant side. That's 1. So, add number yan. Kailangan maging 2 yan. So, ano pwede natin gawin? I-multiply mo to by 2. Okay? So, this is your equation. 2 carbon plus oxygen gas producing 2 carbon monoxide. So, as you can see, check mo yung dami ng atoms. 2, 2, 2, 2. So, balance na yan, no? So, ganun lang yung generic, di ba? Magbibigay na ako ng tips starting this slide. Okay, so ito yung alternate method natin. Kunwari, yung mga numbers dyan, balance na halos, yung isa na lang hindi. You can introduce fractions. Yung ating coefficients kasi, hindi siya limited to integers. No? When I say integer, whole number, no? Hindi siya limited doon. Pwede rin siya maging fraction. No? So, paano tayo mag-iisip ng fraction? Na ganito. Tingin ka sa O2. Hindi natin pwede tanggalin yung isang oxygen atom yan para maging O na lang. Bawal yon. Kasi ibang formula yon, no? So, kailangan O2 talaga. So, isip tayo. Ano kaya pwede i-multiply sa 2 para maging 1? Ano pwede i-multiply sa 2 para maging 1? So, ang sagot doon ay i-multiply mo siya sa fraction. 1 over 2. Yung nasa denominator mo ay yung original number mo para mag-cancel sila. Tapos yung number sa taas, yun yung gusto mong number. Yun yung kaparehas nitong nasa product side. For this case, no? So, ano yung ginawa natin? We will multiply the oxygen by 1/2. Para yung number of oxygen atoms will be reduced from 2 to 1. So, hindi na siya magiging 2. Magiging 1 na siya. Okay? So, ganun yung pwedeng method. Na. So, by introducing this fraction, we multiply 2 by 1/2, we get 1 oxygen atom for the reactant side. Which is the same as the oxygen atom number sa product side. No? So, same na yung kanilang numbers. 1, 1, 1, 1. So, balance na yan. Okay? So, ganun lang. So, ganun yung paggamit ng fractions, no? Paano uli, no? So, tignan mo lang kung ano yung gusto mong gayahing number. Ito yung gusto ko gayahin, 1. So, yun yung numerator ko. Yun nasa baba would be my original number. Yung subscript dito, yung 2. So, yan. So, that's 2 times 1/2 equal 1. No? Ayun lang. Usually, yung fractions ginagamit pala kay oxygen, no? Kay O2. No? Doon talaga siya ginagamit madalas. Mamaya makikita niyo kung ano yung kung saan pa nakikita yan. No? So anyway, so yun. The reactivity balance. No? So, pwede na yan. That's acceptable. However, ito yung however natin. Usually, sa quizzes, no? Sa mga problem sets, ang gusto natin ay whole number. So, kunwari gusto mo ng whole number, pwede naman to. Tama na to eh. Kahit yan na yung gamitin mo, okay lang. Pero kunwari, sabi dun sa quiz natin, no? After this week, may quiz na kayo. Nakalagay doon, what is the whole number coefficient? No? So, ibig sabihin nun, hindi pwede yung fractions sa problem na yon. So, ano gagawin mo para mawala yung fraction? Ganito. You will have to multiply the entire equation by the denominator. ano ba yung denominator dito? 2, di ba? So, ibig sabihin, kailangan i-multiply mo lahat yan by 2. So, by multiplying everything by 2, okay, so magka-cancel yung denominator, magiging times 2 yung carbon, times 2 yung CO, tapos 2 times 1/2 is 1 na lang yung coefficient ng O2, no? So, ganun. As you can see, we still arrived with the same result, no, as what we answered previously, no? So, same pa rin yung mga sagot natin, no? So, ganun lang. You can use fractions, ha? Ayan. So, yan. Pwede gumamit ng fractions. Yan lang. Pero kapag, kunwari, hinahanap sa problem ay whole number, edi para matanggal yung fraction, i-multiply mo yung entire equation by 2. So, mawawala yung fraction. Yan. Ito yung isang tanong sa akin dati ng bata eh. Ano ba yung tanong niya? Sir, possible ba kunwari ito 1/3, ito 1/2, pwede kaya yon? Pwede. Pero hindi ako magbibigay ng ganun, no? So, pwedeng 1/3 to, tapos ito 1/2, no? So, gagawin mo pag ganun, magkaiba sila ng denominator, kunin mo yung LCD nila, no? Kunwari may 1/3 yan, 1/3 element X plus 1/2 element Y. Para matanggal yung fraction, i-multiply mo yan sa LCD nila, which is 3 times 2, 6 lang, di ba? So, magiging 2x plus 3y yan, equals something. Kumbaga parang algebra lang talaga to, no? Algebra lang talaga to. Okay? So anyway, hindi ako magbibigay ng ganyan example. Gusto ko lang is yung isang fraction lang for simplicity. Okay? Pero if ever maka-encounter kayo in the future, ganun gagawin nyo. No? Kunwari, may makita kayong ganyan sa future. After this semester, may makita kayong ganitong problem. So all you have to do is i-multiply mo lang sila sa LCD. No? So ganun lang. So that's the alternate method. Yan yung unang technique. No? Ay, kalawang technique. Ito. So there are times na kailangan i-recognize natin yung type ng equation natin. Kasi in chemical equations, may format yang sinusunod, no? Which we will discuss next week, no? So anyway, mabilis lang kasi yung discussion doon. So anyway, punta tayo dito. So you have this equation. May babansin nyo, may format yan. Ano yung format ng equation na to? So, ang format ng equation for combustion reaction, ito ay combustion reaction. Ang format niyan is CHO plus O2, CO2 plus H2O. So, ganito yung format ng combustion equations, no? So, mapapansin nyo sa combustion equation, usually, sa reactant side, you have your O2. On the product side, you have your CO2 and H2O. No? So, yun yung format niya. Itong CHO, pwede magbago-bago yan. No? However, itong O2, CO2, at H2O, fixed yan. Okay? So, whenever you recognize na meron kang combustion equation following this format, may special steps para dyan. No? Okay, so this time wala tayong O sa CHO natin. So okay lang yon kahit walang O. Usually CH lang talaga. So ganun. So this is still combustion. Okay? So kunwari you encounter this type of problem, uy, combustion to. Ano yung pwedeng gawing technique? So ito yung mga techniques natin for CHOs. No? Number 1, i-balance mo daw muna yung carbon atoms sa product side. No? So that means bilangin mo yung carbon sa reactant side, then i-balance mo yung carbon sa product side. Number 2, balance mo yung hydrogen. Bilangin mo yung hydrogen sa reactant, i-balance mo yung nasa product. Lastly, yung oxygen. Sa pag-count naman ng oxygen, baliktad. No? Kasi dito sa first two, yung product side yung aayusin natin, di ba? Sa oxygen naman, yung reactant side yung aayusin natin. So you count the oxygen atoms here, then saka mo i-balance yung oxygen atoms dito sa reactant side. Okay? So yan na, tapos na yan. Kaya ang tawag ko dyan ay CHO kasi ang method ng balancing dyan ay carbon muna, hydrogen next, then oxygen. So, yan yung pagkakasunod-sunod nila, yung CHO. Carbon first, hydrogen second, then lastly, oxygen. No? So, yung name niya mismo will speak kung paano ibabalance siya. No? So, let's have this for example. Dito tayo. So, we have C4H10, O2, producing CO2, H2O. No? So, sabi, C muna. Balance muna yung carbon. Bilangin mo yung carbon sa reactant side. So, we have 4 carbons here. Sa product side, ito lang yung may carbon. Isa lang yan. So, that's 1. So, anong gagawin? Para mabalance yan, you multiply CO2 by 4. No? So, multiply mo siya by 4. Ayan. So, ayan. So, na-multiply natin yung CO2 by 4. So, we have 4 times the carbon na. Yung oxygen, syempre, magiging times 4 din, no? Plus 1. So, magiging 9 yun, no? So, yun. So, balance na yung carbon this time. So, ano yung sunod na iba-balance? Hydrogens, no? So, we have 10 hydrogens here for the reactant side. We only have 2 for the product side. So, anong gagawin? You multiply your product side by 5 para maging 10 yung hydrogen, no? So, that's 5 times 2, 10, no? Ayan, so we have 5 times 2, 10. So, carbon is already balanced. Oxygen is already balanced. Hydrogen pala, sorry. And oxygen, hindi pa siya balanced, no? So, ngayon, ito yung tanong. How can we balance the oxygen atoms? No? Sabi natin, yung nasa product side, then saka mo i-balance yung nasa reactant side, no? So, baliktad siya ngayon. Yung nasa product muna yung bibilangin, then yung sa reactant yung ibabalance, no? So, bilangin natin kung ilang oxygen atoms meron sa product side. So, this is 4 times 2, 8. 5 times 1 is 1. 5 pala, sorry. So, 8 plus 5, 13. Nag-isip pa tayo, nakalagay na naman dyan, di ba? Okay. So, ito yung number of oxygen atoms na gusto natin. Yan yung gusto natin dami. Sa reactant side, ito lang yung may oxygen, no? O2. So, may dalawa kang oxygen doon. O, isip tayo. Anong number pwede i-multiply sa 2 para maging 13? Gagamit ba tayong fraction dyan? Yes, no? Gagamit tayo ng fraction dito. So, what number should I multiply by 2 para maging 13? So, paano alamin yon? Ganito lang. Yung desired number mo, yun yung nasa numerator. Tapos yung gusto mo i-cancel, yun yung nasa baba. So, 13 over 2 or 7.5. Ay, 6.5. 6.5. Okay, so 13 over 2 yung ating magiging coefficient. Na? Kasi by multiplying 2 by 13 over 2, magka-cancel yung 2. Then you will have 13 na. So same na sila. So maglalagay ka dyan, 13 over 2. Na? So pwede na yan. Okay, so yan. So by adding a coefficient 13 over 2, the number of atoms are already balanced. No? So this is good answer na. Good answer lang. Gusto natin best answer. So ano ba yung best answer? Usually, yung walang fraction. So kunwari, ayaw mo ng fraction, i-multiply mo na lang yan lahat by the denominator. So you multiply the entire equation by 2 para ma-cancel yung fraction. So ganito mangyari. So 2 times this, 2 times 13 over 2, magiging 13 na lang yon. Magka-cancel yung 2. 2 times 4, magiging 8. Then 5 times 2, magiging 10. So the equation is already balanced. No? I-check mo pa. Balance na yan. Okay? So ganun lang. So helpful yung fraction. No? Kasi until this time, nagagamit natin siya. No? So yun lang. Ayun. Next one. Ito, third technique na. So for the third technique, we have this type of equation. Mapapansin nyo, napakadaming atoms. No? Maraming atoms. Nakakatamad siya tignan, di ba? Pero ganito, kung sa CHO may na-recognize tayong patterns, sa ganitong uri ng equation, kailangan may ma-recognize din tayong patterns, no? So kasi ang balancing equation, di lang naman yan counting talaga, no? It's about recognizing patterns, no? Kasi pag nakita mo yung pattern, mas madali na siya i-balance, no? Okay. So tignan natin tong equation na to. Ay, nag-charge na. So let's look at this equation. Ano kailangan natin gawin dito? May i-recognize ka. Ano yung mga pwedeng i-recognize? Polyatomic ions. Tignan mo yung formula. Ano yung nauulit-ulit na pattern? Ano yung nauulit-ulit na equation? So, that's SO3. Mapapansin nyo, nauulit lang siya. May SO3 dito, may SO3 doon. PO4, nauulit din siya. No? So, yun yung third technique na i-share ko sa inyo. Ang third technique involves the recognition of polyatomic ions. So, kailangan i-recognize mo yung polyatomic ions mo. Kasi ang ginagawa ng iba dito, binabalance nila atom by atom, di ba? Huwag ganon. Nakaka-stress yun eh. Ganong ginagawa ko dati eh. Kaya nawalan ako ng gana. Pero yun nga, ganito yung proper method. So, tignan mo kung ano yung mga polyatomic ions nyo. Pwedeng cation, pwedeng anion, okay lang yan. Usually anion, no? So, you have here SO3, naulit siya sa kabila, SO3. Ito, PO4, naulit din sa kabila, PO4. So, you check kung balance yung dami ng polyatomic ions nyo. Paano mo malalaman kung balance yung dami ng polyatomic ion mo? No? So, bilangin mo, ilang SO3 meron ka dito? Isa lang. Isang SO3 lang yan. Isang PO4 lang yan. Isang SO3 lang yan. Isang PO4 lang yon. So kung mapapansin natin, the polyatomic ions are already balanced, no? So whenever they are balanced, iset aside mo na sila. So kapag balance na yan, iset aside mo na sila. Huwag mo na sila pansinin. Balance na yan eh, for now. So ano na lang gagalawin natin para mag-continue sa balancing? Ang gagalawin nyo na lang when you are going to continue to balance the equation ay yung mga natirang atoms, no? Yung partner ng polyatomics, no? So, kunwari, ito, balance na yan. So, yung mga orange circles na lang yung ibabalance pa natin. Okay? So, yung itong N2, H3, H2, and H3. So, yun, ibabalance na lang natin yung mga natira. Okay? So, ganun ha. Recognize the polyatomic ions, no? Then balance the remaining atoms, no? So yan, no? Set them aside, no? Wag mo na muna sila pansinin. Okay? So yan, balance natin. O yung mga polyatomics, wag mo na pansinin. Burahin natin. Ngayon, we're left with Na2, H3, H2, Na3. So let's balance them. Ito, dalawang Na. Ayun, tatlong Na. So, anong common factor nila? Usually, para makuha mo yung common factor, i-multiply mo lang yung dalawang number. 2 times 3 is 6, no? So, kailangan maging 6 yung Na natin. So, ito, para maging 6, you will have to add a coefficient 3. Kasi 3 times 2, 6, no? O, kunwari, ito naman, tatlo na yan. So, ano yung multiply mo sa 3 para maging 6? 2 naman, no? So, yan. So, I will add a coefficient 3 for this formula. I will add a coefficient 2 for this formula. Para tig-anim na yung sodium natin. How about the hydrogens? Ganun din. So, we have 3 hydrogens here, 2 hydrogens here. The common factor is 6. So, for this to be 6, maglalagay ako ng 2 na coefficient. Dito naman, maglalagay ako ng 3 na coefficient. So that means the coefficients, the proper coefficients are the following. 3, 2, 3, 2. No? So yun yung ating mga coefficients na ilalagay. Okay? So this is our final equation, our final balance equation. So 3Na2SO3, 2H3PO4, 3H2SO3, 2Na3PO4. No? So anong pansin natin? Di ba hindi na natin pinansin yung polyatomics? Ganun talaga, wag mo sila pansinin pag balance na sila. Tapos yung natira, yun yung i-balance mo. Then after that, pwede mo na bilangin uli yung lahat ng atoms mo. Bilangin mo na kung gaano karaming sulfur, gaano karaming oxygen. As makikita nyo, balance na lang sila na bigla-bigla na lang sila magbabalance. No? So, ganun. So, yun yung third technique. No? So, the third technique involves recognition of polyatomic ions. Pag may polyatomic ion ka, tapos balance sila, set them aside. Itabi mo lang muna sila. Ang ibabalance mo ay yung partners nila. By balancing their partners, nababalance din sila automatically. No? As shown here dito sa tally table natin. So, balance na lahat ng atoms. Okay? So, paano po kapag hindi balance yung polyatomic ions? So, may example tayo dyan mamaya. No? Pakita ko kung paano kapag hindi balance. Okay? So, ganun lang. So, those are the three techniques that I will share to you. No? Though there are questions na hindi mo sila ma-apply at all. No? Especially if the equation is tricky. So, kapag ganun, balik ka sa basics talaga. No? Back to basic. Pag ganun. Okay? So, yun lang. So, it takes time to practice them, which is okay lang. No? We've been doing this since high school naman. So, sa ngayon, refresher lang naman tayo, no? So, if you're not familiar with the techniques, ayun na yung techniques, no? So, gamitin nyo na yung technique. Ano yung unang technique? Fraction. Pangalawa, yung CHO. Pangatlo, yung polyatomics, no? So, ganun lang. Yun yung ginamit ko dati para mabuhay sa Gen Chem, no? And nakasurvive naman, no? So, kayo rin dapat, no? And ito yung pinaka rule. Do not alter the subscripts. Hindi pwede baguhin yung subscripts, no? Kasi kapag binago mo yung subscripts, you are changing the chemical identity, no? So, hindi na yung chemical compound na yon yung gusto natin, no? Hindi na yun yung pinapatukuyan niya. Okay? So, yun lang yung ating general steps, no? Mamaya na tayo mag-examples. No? Punta muna natin to. So, writing chemical equation out of words. No? Sometimes sa ating equation, sa ating quiz, no? Sa ating activities, hindi sila naka-formula agad. No? So, that means kailangan alam mo yung chemical formula out of the name and vice versa. Kaya nga na-discuss natin yun at first. No? Diniscuss natin yung naming ng formula bago tayo pumunta dito. Kasi important yan. No? Sometimes, yung ating chemical equations ay hindi nakasulat in chemical formulas. Rather, naka-words sila. So, for example, this calcium hydroxide reacts with hydrochloric acid to produce calcium chloride and water. So, out of this equation, out of this sentence pala, you have to create an equation. So, madali lang yan, no? So, kailangan ma-recognize mo yung cations, mga anions mo, yung crisscrossing, how to get the formulas, no? Okay? So, for example, we have calcium hydroxide. Calcium is cation. Metal yan eh. 2 plus yung charge niya. Hydroxide is a polyatomic anion, no? Na may negative 1 charge. So, i-crisscross mo yan. So, yung 2 mapupunta dito. Yung 1 mapupunta doon. So, magiging formula ng calcium hydroxide ay Ca parenthesis OH close parenthesis 2. So, yun yung formula niya. Hydrochloric acid. No? From the word itself, hydrogen, chloric, edi chlorine. No? HCl, acid. So, cation yung H, kaya acid siya. No? So, whenever the cation is H, no, proton, H+, acid yun. No? Okay, so ganun lang. To produce calcium chloride o calcium chloride, cation is Ca2+, an ion is chloride, Cl-. Tapos anong gagawin? Crisscross. So the formula for calcium chloride will be CaCl2. Water, alam nyo na yan, H2O. Okay? So, ganun yung gagawin nyo. From the sentence, you have to identify the chemical formulas. No? So, yan. Kailangan alam mo yung formula ng iyong ions, alam mo yung charges nila, no? Tapos yung pag-criss-cross, kailangan tama, no? So, ganun. Then, ngayon, i-construct mo na yung equation. So, in constructing the equation, meron tayong makikitang keywords, no? So, yung keyword that will tell you kung sino yung reactant, sino yung product, no? At kailan ka maglalagay ng reaction arrow. So, for example, ang keyword natin sa sentence na to ay reacts with at yung to produce. Okay. So, ano meaning ng reacts with? No, nasa word na, reactant, no? So, that means calcium hydroxide and hydrochloric acid, they are both reactants, no? So, reactant yan. Sila yung nasa left side ng equation. Pag nakita mo yung keyword na to produce, anything on the right side of it is product, no? Product na yung nasa right side ng sentence, yung calcium chloride and water. Okay? So, ganun lang yung mga techniques, no? Alamin mo muna yung formula, then identify the keywords, no? Pag nakita mo yung reacts with, that means yung dalawang compound na yon ay reactant. Pag nakita mo yung to produce, anything on the right side is the product, no? So, ayan. Ganito yung example. So, calcium hydroxide reacts with hydrochloric acid to produce calcium chloride and water. So, the formula is CaOH2 plus HCl, arrow CaCl2 plus H2O. So, whenever you have a formula, you have the responsibility to balance it. No? So, kailangan balance parati yung iyong formula. So, in balancing this, you just follow the techniques na shinare ko kanina. Ayan, balance mo na lang sila. Then, you have the balance equation na. Okay? So, ganun lang. Ayun na yun. Balance na yan. Balance mo to ha. Always. Kapag ganun. Kapag may word ka, ibabalance mo talaga yan. Okay? So, bakit kailangan uli i-balance? Because of the law of conservation of mass. No? Yun kasi sabi ng kalikasan. Wala tayong magagawa doon. No? For example, methane burns with oxygen to form carbon dioxide and water. No? So kapag may mga compounds na hindi ka familiar talaga, especially organic compounds, pwede mo i-google naman. Wala naman ako magagawa eh. Teka lang. Okay? So kunwari may chemical formulas na organic compound kasi hindi naman tayo organic chemistry yan. So alam ko di pa kayo familiar masyado, di ba? I don't know if may org chem kayo, no? Pero I hope meron. Anyway, so methane is an organic compound and the formula of methane is CH4 talaga. No? So if hindi kayo familiar with methane, Google nyo na lang. Pero kung familiar kayo, CH4 yung formula niya. Okay? Oxygen, pag sinabing oxygen dito, minsan tukuyan nila ay O2. No? So whenever na makakita kayo ng oxygen o kaya ng air, ang formula na ginagamit doon ay O2, oxygen gas. Ano ba meron sa air? The oxygen gas. No? So, ganun. So, yan yung mga kailangan maging familiar kayo. No? So, kapag sinabing oxygen, O2 yon. Pag sinabing air, O2 din yon. No? So, yan. Carbon dioxide. No? Carbon dioxide, dalawang O2. Water, H2O. No? Tapos keywords ulit tayo. No? So after identifying their formula, identify the keywords. Burns with. No? So burns with, ibig sabihin nasusunog. With, no? So ibig sabihin ng reactant yon. Parang reacts with lang yan. To form. No? So ibig sabihin ng to form, lahat ng nasa right side ay product. So that means the formula can be written as CH4 plus O2 arrow CO2 plus H2O. However, you have to balance it. This follows the pattern for CHO. CHO, CO2, H2O. So, ibabalance mo yan. Carbon first, hydrogen second, then lastly, oxygen. So, you will have this equation when balanced. No? So, always, ang final answer ay balanced equation. Ito yung mga keywords na pwede natin gamitin. No? So these are some keywords that are used to describe whether they are reactant or product. No? So paulit-ulit lang naman to. No? So yan. So ito yung keywords for reactants. Reacts with, combusted with, combined with, the reaction between ... No? So yun yung reactants. Pag products naman, ito yung mga keywords: to produce or produces, to yield or yields, to form or forms, decomposes to produce, so on and so forth na. So yun. So kailangan nag-check din tayo ng sentence natin na. So yun, important yan. So anyway, okay, let's proceed balancing some equations. No? So hindi ko to lahat sasagutan na, kayo na bahala sa iba. So kayo na bahala sa iba, tapos sasagutan ko yung iba din data na. So sige. Since 8 items to, tatlo lang sasagutan ko dyan. Kasi ito, since 5 items to, mga dalawa lang sasagutan ko. Okay, para may matera sa inyo. So, sige, so start tayo. Okay, anyway. So, start tayo. So, let's balance, ano kaya muna, pwede. Tatlo lang muna gagamitin ko ha. Mga representative lang. Ito na lang. Sagutan ko na lang yung 2, 5, and 8. Tapos kayo na bahala sa iba, no? So, keep in mind lang yung mga techniques, no? Sometimes yung technique hindi pwede gumana kasi hindi natin siya magamit talaga. That's okay. Balik kayo sa pinaka-basic, no? So, yung basic counting. Okay? So, ganun. So, try muna natin itong mga items na binilugan ko. So, we have, sulat ko dito sa gilid. C2, okay, so we have this equation, C2H6, O2, CO2, H2O. So, ano yung mapapansin natin? The pattern is CHO. CHO yung pattern, no? So, you have C2H6, O2, then CO2, H2O. So, ang pattern natin dyan ay CHO pattern. So, in order to balance this, we begin with the carbons muna. No? So, carbon muna. So, we have 2 carbons here. We have 1 carbon on the product side. So, I will multiply the product side by 2. Yung CO2, i-multiply ko siya sa 2 para mabalance yung carbons. Next atom is hydrogen. So, yung hydrogen, we have 6 hydrogen atoms here. We have 2 hydrogen atoms on the product side. So, this is 3, this is 6, this is 2. So, ano yung multiply mo sa 2 para maging 6? That would be 3. No? So, I will multiply H2O by 3 para maging balance yung hydrogens. No? Next one ay oxygens. No? So, in balancing oxygens, you count the oxygen atoms in the product side muna. No? So, ilang oxygen atoms meron tayo sa product side? So, that's 2 times 2. This times 2 plus 3 times 1. Isa to times 3. So, yan. Pag-add natin yan. 4 plus 3, 7. 7 yung ating oxygen atoms. Sa reactant side, you have 2 oxygen atoms. Got time border. So, 2 oxygen atoms yung meron ka. Sa product side, you have 7. So, ano yung pwede i-multiply sa 2 para maging 7? So, pwede mo i-multiply sa 2 para maging 7. That is 7 over 2. 7 halves, no? So, magka-cancel yung 2. You will be left with 7 number of atoms, no? So, i-multiply ko to by 7 over 2. So, this equation is actually okay na, no? Pwede na yan. However, the final answer is always written with a whole number coefficient. Open ko lang muna. So, in order to make this a whole number, no? So, multiply everything by 2. So, multiply mo yan by 2. So, the 2 sa fraction will be cancelled, no? So, the final equation would be 2C2H6, 7O2, producing 4CO2 plus 6H2O. Tama ba? 2, 7, 2 times 2, 4, 3 times 2, 6. So, this is the final equation. Okay, so that would be the final equation for number 2. No? Ngayon, punta naman ako sa 5. No? So, for number 5, I have here Al plus sulfuric acid producing aluminum sulfate and hydrogen gas. Okay, so we have this equation. No? Ano pwede natin gawin? Sabi ko sa inyo last time, kung may pattern na pwede ma-recognize, i-recognize. No? So ano kayo nauulit dyan? Yung SO4. No? So as you can see, we have SO4 here. Another SO4 there. No? So yung SO4 natin that exists no, sa left and sa right side ng equation. However, the question there is balanced ba yan? Balanced ba yung SO4 natin? Tignan natin. Ilang SO4 meron dito? We have 1. Isa lang tong SO4. Dito sa product side, we have 3. Paano mo nalaman na 3? Tignan mo yung subscript ng parenthesis. No? So, our parenthesis has this coefficient, subscript na 3. So, itong 3 na to, that tells you na may tatlo kang SO4. Okay, so tatlo yung SO4 natin. So, anong gagawin mo? So, kanina, di ba, balance yung ating polyatomic ions. No? This time, hindi sila balance. So, kapag hindi sila balance, sila yung unang ibabalance mo. No? So, unahin mo sila i-balance. So, paano yon? Ganito lang. Sila yung unahin mo. Sila yung lagyan mo agad ng coefficient. No? So, we have 3 SO4 here. Tatlo yung SO4 natin. Tapos dito, isa lang. So, ibig sabihin, kailangan ko to gawing tatlo. So, paano? Siyempre, hindi ako pwede maglagay dyan ng subscript. No? Bawal yon. Ang pwede ko lang ilagay ay coefficients. No? So, in order to balance this, maglalagay ako ng coefficient na 3 kay H2SO4. So, by placing this coefficient, yung SO4 ko ay magiging times 3 na rin. No? So, may tatlo akong SO4 dito. Ngayon, may tatlo din akong SO4 dito. So, balance na yung SO4. So, natitira na lang ay yung Al pati H. No? Balance natin yung Al. We have 1 Al here, 2 Al there. So, para mag-balance yon times 2 lang yung nasa reactant. I have 3 times 2, so 6 hydrogens. I have 2 hydrogens on the product side. So, parang itong 2 sa product side maging 3. I-multiply ko yan sa 3. Okay? So, this is the final equation for this problem, no? So, yan yung ating final answer sa problem na yan, no? Hindi ko naburahin. Okay, so let's have this last item. So we have here beryllium carbide plus H2O producing beryllium hydroxide and methane. Ito question, no? Can we recognize patterns? Hindi na, no? So wala na akong makitang pattern sa ngayon, no? So kung gano'n, wala ka na makitang pattern, then you start balancing them the usual method, no? The usual way. So paano yung balancing them in a usual manner? So usually left to right, no? Balance natin yung beryllium. So I have 2 beryllium here. Isa lang dito. So that's times 2. Okay? So balance na yung beryllium. Next one, carbon. So isa yung carbon ko dito, isa doon. Balance na yon. Wala na akong gagawin. Hydrogen. So ilang hydrogen meron ako dito? So I have 4 hydrogens here. So ilan dito? This is OH, tapos may 2. So, ibig sabihin, may dalawang OH, may dalawang hydrogen, times 2 uli. Kasi may dalawa ka pa dun sa coefficient. So, that's 2 times 2. That means 4. So, that means I have 8 hydrogens. Sa reactant side, I only have 2 hydrogens now. So, to balance that, maglalagay ako ng 4 para 8 na yung aking hydrogen. No? Okay, so balance na yung aking hydrogen. Lastly, oxygen na lang. No? So I have 4 times 1. So I have 4 oxygens here. Then dito, tignan natin. Ilang oxygen meron ka? This is dalawang OH. So may dalawang O times 2. So that's 2 times 2. Oops. So that's 2 times 2 equal 4. No? So balance na yung oxygen. Balance na yung hydrogen, balance na yung beryllium, and balance din yung carbon. Okay, so basically balance na lahat. No? So whenever all the techniques fail, you have to do it manually. No? Yung isa-isahin mo talaga sila. Next one. Ito naman, bago tayo mag-next one. So kayo na yung magsasagot na ito, no? Burahin ko lang. Ano yung sinagutan ko? Kaya na yung mag-a-answer naman na ito. 1. Yan. Answer in Canvas. Okay, so ganun lang. So, yung mga naka-blue highlight, kayo na lang po magsagot niyan. Post nyo na lang sa Canvas yung answer ninyo. Next one, we have this following compounds, following examples here. So, balance the following reactions. Ano kaya pwede ko sagutan dito? 1 and 2 na lang. Tapos kayo na bahala sa 3, 4, 5 na. So, ganun din, answer nyo na lang sa Canvas. Sagutan ko yung 1. Na? So, glucose is combusted with oxygen to produce carbon dioxide and water. So, yung word na combusted with, that means reactant yung glucose and yung oxygen. So, the glucose, if hindi kayo familiar, Google nyo na lang. That will be C6H12O6. The formula for oxygen is, sabi natin, O2, di ba? Then, to produce, so ibig sabihin yan, arrow, no? To produce carbon dioxide and water. So, that will be CO2 and H2O. Okay? So, this is our formula. So, syempre, yung formula mo, hindi yan tama kapag hindi yan balance. So, kailangan natin i-balance yan. So, you can see this follows the pattern of CHO. No? So, nagpa-follow yan ng CHO pattern. So, that means i-balance muna natin yung carbon. I have 6 carbons here, 1 carbon there. So, this is times 6. Okay. I have 12 hydrogens here, 2 hydrogens there. So, kailangan ko i-multiply yung 2 sa 6 para maging 12. Then, count the oxygen sa product side. So, on the product side, I have 6 times 2. 6 times 2 plus 6 times 1. So, that's 6, 12, 18. So, I have 18 oxygens on the product side. Sa reactant side, ilan meron ako? So, this is 6 times the coefficient 1 plus 2. So, ilan to in total? So, 6, 8 lang yung aking oxygens dito. So, may 6 na ako. Tapos, may 8, no? So, ano kailangan ko gawin? Kailangan ko gawing 18 to, no? So, ang pwede natin gawin dito is magbawas tayo ng 6 on both sides, no? So, tatanggalin ko itong 6 dito. Tatanggalin ko rin yung 6 doon. Okay? So, ilan na lang kulang? This is 6 times 2. This is 2. So, kailangan, obviously, may 6 din doon, no? So, maglalagay ka ng coefficient na 6 for this O2. Okay? So, that is our answer for number 1. No? So, that's number 1. On number 2 naman. Methanol. Ano yung formula ng methanol? That's CH3OH. Combusted with oxygen to produce carbon dioxide and water. Okay? Ganun pa rin pala yung pattern, no? So this is our equation, CH3OH, that's methanol, plus O2, RO, CO2, and H2O. Balance muna yung carbons. I have 1 carbon here, 1 carbon there, so okay na yun. Ano na akong gagawin? I have 4 hydrogens here, 3 plus 1, 4 hydrogens. Dito, 2, so times 2 yung product. As oxygen na tayo. Bilang tayo oxygen. 2, 1 times 2, 2. So that's 4. Sa reactant side, ilan meron? Meron akong 1 plus 2. May 3 ako. So similarly, pwede natin gawin, mag-subtract tayo ng 1. No? Mag-minus 1 tayo. Usually, ito yung tinitira talaga, yung sa O2. No? Tatanggalin mo yung mga nandito sa CHO. No? So ito, tingin tayo dito sa O2. So ilan meron na? May 2 ka na lang ditong natira. Tapos sa product side, since binawas natin yung isa, may 3 ka pang kailangan. No? So anong gagawin natin para yung 2 maging 3? So para mag-equal sila, I will multiply 2 by 3 halves. No? Kailangan ko siya i-multiply by 3 halves. So magka-cancel yung 2. Matitira ay yung 3. No? So that means the final equation would be CH3OH plus 3 halves O2 CO2 2H2O. Okay? But, of course, the best answer would be yung whole number yung ating coefficients. No? So, para maging whole number yung coefficients, multiply mo lahat by 2. Okay, makakancel yung 2 sa baba. So, the final equation talaga would be 2CH3OH plus 3O2 2CO2 plus 4H2O. So that would be our final answer. Okay, so ganun lang. So again, sulat ko na lang dito. Answer in discussions. Canvas. So yan. Answer nyo na lang yung mga naka-highlight sa blue sa canvas. No? Okay, so we're done with the third part of our lesson. No? First part is yung molecular mass. No? Second part is yung percent composition. Third part, itong balancing equation. Then pupunta na tayo sa fourth part. No? So the fourth part would be on stoichiometry. So magko-continue na ako with stoichiometry. Okay? So screenshot ko na ba? Okay. So ganun lang, no? Kailangan check ko lang kung ano yung kailangan i-cover sa stoic. Bukas pala yung Facebook. Okay. Na-discuss na pala natin yung mass mole conversion na. Oo, na-discuss na natin last time. Okay, so ngayon, stoichiometry na tayo. Okay, so let's proceed with the stoichiometry. So when you say stoichiometry, ang meaning lang nun ay stoichiometros, counting substances. No? Magbibilang lang tayo ng substances involved in chemical equations or chemical reactions. So formally speaking, stoichiometry is the quantitative relationship of the amounts of reactants consumed and the products formed in a chemical reaction expressed by a balanced chemical equation. So yun, it follows the law of conservation of mass. No? So yun lang. So yun yung stoichiometry. Ano yung mga kailangan dyan? Balance equation. The idea ng mass-mole relationship. No? So kailangan yung mga bagay na yon in solving stoichiometric problems. No? So how do we approach this problem? No? Paano natin nalalaman yung amounts ng reactants and products natin in a chemical reaction? So ganito. So the answer would lie on your chemical equation. Once you have balanced it, no, you will have idea now about the proportion of your chemical substances in the equation or in the reaction. So let's have this balanced equation, N2 plus 3H2 producing NH3 gas now. So the stoichiometric relationships are the following. No? So paano natin malalaman yung stoichiometric relationships? So the stoichiometric relationships or yung ratio nila, that depends on your coefficients. No? So tingnan mo, we have one coefficient for N2, 3 coefficient for H2, and 2 coefficient for NH3. Yung mga coefficients natin, actually, they tell us about the number of moles of your substance. No? So that means 1 mole N2 is needed to react dito sa equation. 3 moles of H2 is needed to react sa equation na to. And 2 moles NH3 will be produced in this equation. Okay, so anong ginawa natin? Yung coefficients natin, we converted them into moles. No? So 1 mole N2, 3 mole H2 produces 2 mole NH3. How do we get the stoichiometric relationships? No? So ganito lang yun. No? Parang 1 mole nito equal sa 3 moles ng H2. Nito equal sa 2 moles ng NH3. 3 moles nito equal sa 2 moles ng NH3. So, ganun lang yung idea dyan. No? Kumbaga, sila ay, yung coefficients, naging ratio lang sila. So, kunwari, isang part nito, 3 part nun kailangan. Isang part nito, 2 nung kailangan, 3 nito, 2 nun ang mapoproduce. No? So, yun. Para siyang recipe, no? Kasi, di ba, pag nagluluto tayo, may 3 cups of ganito. Kunwari, 3 cups of flour, tapos 5 pieces of egg, no? So, yun yung mga stoichiometric relationships, no? Sa chemical equation that can be observed as the coefficients, no? So, ito yung ating mga coefficients. So, sila ang ating mga stoichiometric relationships, no? And we can use them as conversion factors, no? So we can use them as conversion factors in converting 1 mole of a substance to the other. No? So ganun lang. So let's have this. No? So if we have 15 moles of N2, how much NH3 will be produced? No? We begin with the mole N2. No? So we begin with 15 moles of N2. Gano daw kaya karami ang NH3 na mapoproduce? Basically, magko-convert lang tayo. You convert the moles of N2 into the moles of NH3. No? So you begin here with mole N2 times the conversion factor for N2 and NH3. Saan natin nakuha itong 1 mole N2, 2 mole NH3? So sila ay makikita sa balance equation. So importante na balance yung equation mo talaga. So the balance equation tells us 1 mole N2 will give us 2 moles NH3. Okay? So ganun lang, use that as conversion factor. Mole N2, nasa baba yung mole N2 para mag-cancel yung N2. And NH3 sa taas na. As that is your desired unit. Na. So kung naalala nyo pa yung lesson natin, chapter 1, conversion, ganun din ginagawa dito. Conversion lang. So that's 15 moles times 2 over 1. So that will give you 30 moles of NH3. Okay, so ganun lang. So ito yung typical scheme ng pag-answer ng stoichiometric problems, no? So ganyan yung ating typical method sa pag-answer ng stoichiometric problems, no? So you solve for the mass-mole relationship if necessary. Kapag given yung mass, edi kailangan mo i-convert sa moles yon. Kung gusto ng mass, edi i-convert mo yung mole to mass, no? So kailangan alam niyo yung conversion ng mass and mole. And that can be solved using this triangle, no? Ay, lang. This is mass, mole, molar mass. You can use this triangle in converting mass to mole. You know how to use this, no? So gamitin nyo na lang. Then, whenever you are converting a mole of one substance to the other, you should have a balanced chemical equation. You have a balanced chemical reaction, no? So ganito yung scheme, no? So you're given with grams of your initial substance or moles of your initial substance. Then, i-convert mo siya into moles of the other substance, no? Ito yung gusto mo hanapin, yung other substance. Okay? So, ganun lang ang technique dito. So, yan yung mga usual na ginagawa, no? So, I will have, let's do some problems, no? Gawin ko na lang yung nandito sa PDF natin. For example, let's have this one. Number 3. We have this. Glucose is combusted with oxygen to produce carbon dioxide and water. In a certain process, 968 grams of glucose is consumed. What is the mass of carbon dioxide produced? No? So, yun yung tanong sa atin. No? Ano kailangan pag stoichiometry? Balance equation. So, gumawa ka na ng balance equation. So, from words to, walang equation eh. Tayo gagawa ng equation. So, glucose, C6H12O6, is reacted with or combusted with oxygen to produce carbon dioxide and water. So, once you have the equation, you have to balance it, no? So, na-balance na natin to kanina. 6 lang yung kanyang coefficients, no? So, yan. In a certain process, ito na, stoichiometry na tayo, no? So, once na may equation ka na, you can now proceed to the next part of the sentence, of the problem. No? In a certain process, you have 968 grams of glucose is consumed, no? Ayan. What is the mass of CO2 produced, no? Okay, so anong gagawin natin? So sinasabi lang sa problem, you have to convert 968 grams of glucose into what mass of CO2? Ano daw kaya magiging mass ng CO2 given this amount of glucose? No? So solve natin yan. No? So paano? Gawa ka muna ng scheme. So paano uli yung scheme natin? Kung naalala nyo kanina, mass A, convert to mole A, convert to mole B, convert to mass B. Okay? So, ito yung typical scheme. Yan yung pattern natin. No? Ito yung sinusundan natin. Convert mo yung mass ng given into mole of given. Then, i-convert mo yung mole of given to the mole of the required substances. No? Tapos, pwede mo i-convert yan to mass. No? So, again, yung A and B, these are our given substances. Yung mga B, yan yung ating desired. Teka lang. Okay, so yan. So A is your given, B is your required, no? Or yung desired, no? So sabi sa problem, ano yung given? So given yung glucose, no? So that means ito yung glucose natin. Yung B, yung gusto natin, which is CO2. Ito yung desired, no? So substitute lang natin yan dito. Palitan lang natin yung scheme. So alam na natin yung substances, no? So we convert mass ng glucose into mole ng glucose. Then, yung mole ng glucose, i-convert to mole ng CO2. Then, finally, mole ng, hindi mole, mass ng CO2. Okay, so ganun yung ating magiging scheme. So, identify mo muna sino yung given substance, then sino yung gusto hanapin, then gawa ka ng pattern na to. Siyempre, kapag master niya na to, hindi nyo na kailangan to gawin talaga. Although, it would be nice, no, if meron kayo nito mismo para alam niyo kung ano yung mga sinusundan. Anong step na kayo, no? So, ilang calculations meron dito? Bilangin mo lang yung araw. 1, 2, 3. Oh, you have to do 3 calculations, no, to answer this problem. Tingin tayo sa part 1. So, the first equation, the first calculation involves the conversion of mass of glucose to mole of glucose. Paano yan sinasagutan? Mass-mole relationship lang yan. So, we can use the triangle, no? So, you have the mass, the mole, and the molar mass. Ano hinahanap? Mole. So, since mole ang hinahanap, we have to divide mass by the molar mass. So, yan. Kunin lang natin yung equation. Mole glucose, ganito na lang. Mass glucose over the molar mass of glucose. Ano yung mass ng glucose na? 968 grams. O, divide mo yan sa molar mass ng glucose mo. Calculate natin. 6H12O6. So that would be 180.156 G mole. Okay, so this is our conversion ng mass ng glucose into moles of glucose. The grams will cancel out. 968 divided by 180, 156. Kopyahin nyo lahat ng digits. No? Kopyahin nyo muna lahat. Huwag tayo magra-round off. No? Again, kopyahin lahat ng digits. Ha? Sa dulo na tayo mag-round off. So this is 5, 3, 7, 3, 1, 2, 1, 0, 7, 3 mole. Okay? Oops, kulang ng space. Anyway, number 2. So, yan. Tapos na natin yung first part, no? Second part tayo. Teka lang. Adjust ko to para may space. Okay, so number 2 na tayo. So for number 2, dito na tayo sa part na to. We have to convert glucose to CO2. So how can that be done? Paano ginagawa yan? We have to do stoichiometry. So just look at the balance equation. Tingnan mo yung coefficients ng glucose and ng CO2. So according to the balance equation, 1 mole ng glucose, according to balance equation, according sa balance equation, 1 mole ng glucose is equal to ilang mole ng CO2. Kunin natin yung conversion factor. 1 mole ng C6H12O6 is equivalent to 6 CO2. Yan. So 1 is equal to 6, no? 1 to 6 ang ratio nila. So ngayon, i-convert na natin yung mole ng glucose, which is this number. Yan, ko-convert natin yan into mass na, mole ng carbon dioxide. So convert natin yan into mole CO2. Highlight ko nga yung mga sagot natin yan. O, convert natin yan to mole CO2. That is mole glucose times the conversion factor. 1 mole C6H12O6, 6 mole CO2. So, ayan. Hindi ko na ito type to ka. Nahaba eh. Multiply ko na lang to dito sa 6 over 1. So, times 6. So, that's 32 to 8. Ay, hindi. Ano yun? 238 7 to 6 44 mole CO2. Okay? By the way, yung glucose magka-cancel out, ha? Okay, so this is our answer for the second part, no? We have CO2 na. That's good. Punta tayo sa last part. Mass ng CO2. Paano kinukuha yung mass ng CO2? From the mole of CO2, kukunin yung mass. So you can use the triangle, mass, molar mass, mole. So to solve for mass, that is mass times the mole. Molar mass times the mole lang. Okay? So, yan. Mass CO2 mole CO2 times the molar mass CO2. Sulat ko na nga. 32 238 72644 times 44. Okay. Mass CO2 times 32 to 38 726 44 1418 on 2 decimal places na lang, ha, grams, no? So this is our final answer. So yan. So out of 968 grams of glucose, we can produce 1.4 kilos of CO2. So ganun, ha. So ganun lang yung conversion niya. Basically, umiikot lang tayo sa dalawang solving. 2 of which gagamit ng triangle, yung mass-mole relationship, no? So yun yung first part and the third part ng equation. Yung second part, ito lang yung stoichiometry. So ano lang yung kwento dito? Conversion lang yan ng mole ng given substance to the desired substance, no? You can get the conversion factor sa balance equation. So yun lang talaga yung stoichiometry, no? Alam nyo na mag-convert ng mass to mole. Ang nadagdag lang is yung conversion ng one substance to the other from the balanced equation, no? So ganun lang. Easy lang, no? So ganun. It takes time. Practice lang. Again, wag kayong mag-round off. Sa dulo na kayo mag-round off na. Sa final answer. para walang sayang na digits. Let's have this one. Number 4. Hindi ko to sasagutan lahat Kayo na bahala sa iba. Sige, sasagutan na lang. Sasagot lang ako ng isa pa. Methanol is combusted. Hindi. Sige, tatlo na sasagutan ko. Para marami kayong pagpipilian. Marami kayong examples. Methanol is combusted with oxygen to form carbon dioxide and water. Gawa ka ng equation out of that. Matik yun, ha? So, methanol, CH3OH, oxygen, O2, to produce CO2 and H2O. Na-balance na natin to, di ba? Nakalimutan ko lang. So, this is 2, 2, 2, 4, 1, kailangan maging 3. So, 3 halves. Okay, so this would be 2, 3, 2, and 4. Kung tama yung pagkakaalala ko, yan yung coefficients. Of course, kailangan importante na. Importante talaga dito na tama yung balancing mo. Check ko nga. Dalawang carbon. 4 times 2, 6. 8. No. 4 times 2, 8. 8. Okay. Tapos, 2 plus 6, 8. 2, 2, 4, 4, 1, 0, 8. Ayan. So, tama. Balance na yung equation natin. Okay, so once you have the balance equation, proceed ka na sa next part ng question. If 209 grams of methanol is used up in a process, what is the mass of carbon dioxide and water produced? No? Ano daw yung mass ng CO2 at ng H2O na mapoproduce? Okay? So, dalawang questions to. So, sasagutan ko na to. Dalawa yung hinahanap eh. Okay? So, syempre, isa-isa lang, no? Sagutan muna natin yung CO2 bago yung water, no? Now, gawa tayo ng scheme. So, yung way ng pagsagot natin. So, we begin with mass, ano to? Methanol. Iko-convert mo yan to mole methanol. Then, iko-convert mo yan to mole ng CO2 or ng water. Then, eventually, mass ng CO2 or H2O. Okay? Dalawa kasi pinapahanap sa atin. So, dalawang beses tayo maggagana na. So, sa last part lang. Okay? So, we have 3 steps in answering this question. So, may tatlo tayong steps, no? Okay? So, ganun ha. Yung scheme na to, paulit-ulit lang yan. Mass ng given substance, mole ng given substance, mole ng desired substance, and yung mass ng desired substance. Yun yung format. Ito yung format kung makalimutan nyo na. Saan na yun? Ito yung format ha. Ayan. Ayan ang format. So, ayan yung ating scheme. So, paulit-ulit lang yan. So, save nyo na yan. No? Okay. So, sige, answer tayo. On first part. First part. That's mass of methanol to mole methanol. So, mass-mole relationship lang yan. How are you going to convert mass to mole? That is mass methanol divided by the molar mass ng methanol. Ito, 209 grams molar mass. Wait lang. That would be 32,042. Cancel yung grams, okay? Kopyahin lahat ng digits. 6.52 to 688,971 mole. Okay? So this is our answer for the first calculation. Yan yung mole ng methanol. Second part. Sa second part, dalawa yung sasolve natin. Dalawa kasi hinahanap. I-convert natin yung mole ng methanol, detong number na to, into CO2 and H2O. So, paano yung gagawin? Just look at the balance equation. Kunin mo yung conversion factor. Okay. So, sa part 2, ba't naging ganun? For, CO2, paano yung, for CO2, gawin mo lang, mole CO2, naging makapal yung ink. Yan. That is just the mole of methanol times the conversion factor, which you can see sa balance equation. No? So, nasa baba yung mole ng methanol, nasa taas yung mole ng CO2. Purong ko lang konti. O, tignan nyo yung coefficients. So, dalawa for methanol. So, 2 mole methanol. For CO2, that's 2 then. So, 2. Okay. So, basically, the same number lang pala. No? So, you will have... Teka lang, ilipat ko nga ito sa gilid. Oops. Oh. Teka, lipat ko na lang sa kabila. No? So basically, you have the same number, 6.522,688,971 mole. CO2 na siya this time. So cancel na yung methanol. For naman, for H2O, that's mole H2O equal mole ng methanol times the conversion factor. Siyempre, nasa baba yung methanol, nasa taas yung H2O. Then, look at the balance equation kung ano yung coefficients nila. So, for methanol, that's 2. For H2O, that is 4. Okay, so basically, magiging times 2 lang yung dami. No? Times 2 ko nga. Times 2. So, that would be 13, 0, 4, 5, 3, 7, 7, 9, 4 mole H2O. Okay, so yan yung mole ng H2O natin. Okay, so ganun lang gagawin nyo sa stoichiometry part. Conversion lang talaga siya. So you have the mole of methanol, kinonvert natin siya into CO2 and H2O. So paano ginagawa yung conversion? Tingin ka lang sa balanced equation. Doon ka lang titingin kung ano yung kanilang coefficients. 2 for methanol, 2 for CO2, 4 for H2O. So yun yung mga gagamitin nyo lang. O, last part, no? Number 3 na tayo, conversion. So that's the conversion of moles of CO2 and H2O to mass of CO2 and H2O, since yun yung hinahanap sa problem. Okay, so dito na lang sa pinakababa. Yan. So number 3, mass ng CO2. So how do we solve for mass? Mass over molar mass lang yan, no? I mean mole times the molar mass. Molar mass ng CO2. Okay.
diretsuhin ko na para mabilis na. Ano molar mass ng CO2 ulit? 12,011 times 2. This will be 287.06 grams CO2 at ang mass ng ano yun? H2O would be mole ng H2O times the molar mass ng H2O. 13,045,377.94 times mass ng H2O 008 times 2 plus 15,999. So that's 235.01 grams ng H2O. Okay, so ito na yung final answer natin now. So these are our final answers. No? So yan yung mass ng carbon dioxide at mass ng water. May isa pa palang tanong dito, how mass ng oxygen? Oh, dami pala. So yung mass ng oxygen, madali lang yan. No? Sama natin dito. Nakalimutan ko. So sa second part dito tayo. For O2. Kalimutan ko yan. Mole ng O2. Mole ng CH3OH times the conversion factor lang ulit. No? Mole ng CH3OH. Dalawa yon. Mole ng O2. 3. 3. Ito 2. No? So solve natin yan. That is given as, teka lang, dami palang hinihingi dito, no? $9.784033,457 mole. Then to solve for the mass of O2, that's simply mole O2 times the molar mass O2. Final answer na agad para mabilis. Times 313.07 grams. Okay, so that is our solution for this problem. No? Send ko na lang sa group chat natin, no? Para mas malinaw yung picture. So anyway, so ganun lang yung stoichiometry. You begin with converting mass of your given substance to mole of the given substance. Then yung mole ng given substance mo, i-convert mo siya to to mole ng desired substance mo. In this case, CO2, H2O, and O2. Then, finally, i-convert mo sila into mass. No? So, ganun lang. No? So, send ko na lang to sa GC natin. Okay. For the second to the last part, punta naman tayo sa limiting and excess reagents. No? So, anong kwento naman ng limiting and excess reagents? Ganito lang yun. No? Usually, in chemical reactions, yung ating substances ay sobra-sobra. Parang pag nagluluto tayo, di ba? Kunwari, bibili ka ng bigas, no? Nagluluto ka. Hindi naman lahat yun gagamitin mo, di ba? Kunwari, bumili ka isang sako, hindi mo naman uubusin yun lahat, di ba? Konti lang yung gagamitin mo, which is enough, no? Para sa lahat. Ganun din sa chemical reactions, no? Sa chemical reactions, you have lots of chemicals around you. Marami kang ingredients. Pero hindi lahat ng ingredients ay gagamitin mo. May mauubos na ingredient at mayroong sobrang ingredients. Ang tawag sa kanila sa chemistry ay limiting and excess reagents. The limiting reagent or the limiting reactant is the substance which is consumed agad after the chemical reaction. So, kumbaga, pag nagluluto ka, ito yung kapag ubos na siya, hindi ka na makakagawa ng products. So, yun yung limiting reagents. Pag sinabi namang excess reagents, ito yung mga substances na sumobra man, okay lang. Sumobra man siya, or matapos man yung chemical reaction, may sobra pa rin. So, that means hindi sila naka-apekto masyado sa reaction mo, no? Kasi sobra-sobra sila. Kaya nga excess reagent. Again, ano lang yung konsepto? So, kapag limiting reagent, ito yung reagent, ito yung reactant na nauubos agad. As a result, pag nauubos siya, hihinto yung reaction. So, that means if the limiting reagent is consumed agad, that means tapos na yung reaction. Yung sumobra na isa pang reactant, that is your excess reagent. No? So your excess reagent will not totally be consumed. Hindi siya agad-agad mauubos. Kaya nga excess, di ba? So ganun din sa chemical reactions. No? So paano po natin malalaman kung sino yung limiting, sino yung excess reagents? Ganito lang yan. Madali lang naman. So magko-convert lang tayo. Stoic lang tayo. So, for example, we have this one. Let's have this example, number 1. Methanol is produced from carbon monoxide and hydrogen gas. Gawa tayo ng equation out of that. So, methanol, this is your product. Is formed from. Meaning ng from reactant tong mga to. Okay? So, ito yung reactants mo. CO, carbon monoxide, and hydrogen gas that will produce methanol. Ayun, sabi ng problem balance natin. Para mabalance yan, lalagyan ko lang to ng 2. Yeah, okay. So, balance na yan. So, this is our equation that we will need, no? Whenever we are doing stoichiometric calculations, no? Okay. So, yan. Suppose we have 4 moles of CO. 4 moles daw neto. And 6 moles neto. Sino sa dalawa ang limiting at excess reagent, no? So we begin with 4 moles carbon monoxide and 2 moles ng hydrogen gas. Determine the limiting and the excess reagent. No, ito yung technique lang dyan. The technique is to convert your moles or your mass or the amount of your reactants, no? Dalawa sila. I-convert mo yung dalawang yon into a product, yung gusto mong product. Okay? So, gawin natin yon. So, since dalawa yung ating reactants, alamin natin kung gaano karami yung products na pwede nilang i-produce. So, let's begin with mole of methanol from CO and mole of methanol from H2. So, ganito po yung ginagawang method dito, no? So, aalamin mo kung gaano karaming product ang mapoproduce mo out of the 2 reactants, no? So, for CO muna tayo. Mula sa CO, so we have 4 moles of carbon monoxide. Iko-convert natin yan into moles ng product, no? So, hanapin ang conversion factor na sa balance equation. So, 1 mole CO, 1 mole CH3OH. So, magka-cancel yung CO. And we will have 4 moles of OH from CO. Okay? So, doon galing yan So, i-recognize natin na 4 moles yung kaya i-produce ng carbon monoxide. Okay, H2 naman tayo. Convert natin yan papunta sa moles ng product. 2 mole H2 1 mole CH3OH. Okay? So, cancel mo yung H2. So, that's 6 divided by 2, 3. So, 3 moles CH3OH from H2. Now, isip tayo. Sino yung excess reagent? No? Gaya nga ng sabi ko kanina, yung limiting reagent, yun yung nauubos agad sa chemical reaction. So, since siya yung nauubos agad yun, hihinto agad yung reaction. So, as a result, konti lang yung mapoproduce niyang product. So, ang limiting reagent siya yung substance that will give you the least amount of product. So, sino sa dalawa yung least amount yung binigay? Is that the carbon monoxide or hydrogen gas? Siyempre, yung H2 yung nagbigay ng least amount ng product. So, yung least amount ng product na binigay ng H2, that indicates na ang H2 ay limiting reagent. No? So, siya yung limiting reagent natin. So, that means yung carbon monoxide, this will be our excess reagent. Okay? Kasi sobra yung nabigay niyang product na. So, hanggang 3 moles lang yung kaya natin gawin. No? Nari, tinanong sa inyo, ano yung theoretical yield? No? So, ang theoretical yield naman, ito yung dami ng product na magagawa mo out of your limiting reagent. So, kung ilang moles ng product yung nabuo ng limiting reagent mo, yun yung theoretical yield. Hanggang dun lang yung kaya ng reaction. So, the answer here would be 3 mole of methanol only. So, hanggang dun lang. Hindi na pwede maging 4 moles kasi ubos na yung H2 nun. Hindi na siya makakagawa ng sobra pang methanol. So, hanggang dyan lang yung kaya niya. Okay, so ganun po yung pag-identify kung sino yung limiting, sino yung excess, at ano yung theoretical yield. Again, limiting reagent will produce the least amount of product. The excess reagent will give you the most amount of product. Yun siya yung sobra-sobra dami. No? Sobrang daming product na mapoproduce. Sino sa dalawa yung theoretical yield? Sino yung sa dalawa yung actual na dami ng products na mabubuo mo after the reaction? Of course, yung smallest number, yung smallest mole. So, ito lang yung, hanggang dito lang yung kaya. Hindi na niya kaya makagawa ng 4 moles kasi ubos na yung H2 that time. Okay? Sasagot pa tayo ng isang item. Let's do this. Ay, daming numbers. Ito na lang. So, I will try this, number 3. Yung number 2 kasi, kilo-kilo eh. Nakakatamad. Number 3. The reaction between aluminum and iron 3 oxide can generate temperatures approaching 3,000 degrees Celsius and is used in welding metals. So, this is actually called the the thermite reaction. In one process, 124 grams of aluminum are reacted with 601 grams of iron 3 oxide. Calculate the mass of aluminum oxide formed and how much excess reagent is left at the end of the reaction. Sagutan muna natin yung A, syempre. No? So, may balance equation ka na. Balance yan. So, nothing to worry. We can now solve for the amounts of aluminum oxide produced. No? Ano muna gagawin mo? Scheme. Yung mass ng reagent mass ng reactant na i-convert mo to mole reactant. Then yung mole reactant i-convert mo to mole aluminum oxide kasi yung required sabi dito sa problem. Then kunin mo yung mass ng aluminum oxide na mapoproduce na. Kailangan buuin natin to. Mass. Okay, so ganun lang yung ating method na. So, medyo marami tayong steps. Yes, wala tayong magagawa doon. Marami talaga. Anyway, so alamin muna natin yung moles ng reactant natin. No? So, teka lang. Part 1, Part 2, Part 3. Part 1. Solution A yan. So, Part 1, yung mass ng reactant, i-convert natin to moles na. So, convert natin yung mole aluminum. Hanapin natin yan, pati mole ng Fe2O3. So that's mass aluminum, molar mass aluminum, mass Fe2O3, molar mass Fe2O3. So this is 124 grams, 601 grams. Medyo marami lang sinusolve. Ganun talaga. Ano to? Aluminum lang, di ba? So ang aluminum, that's 26,982 grams per mole. Okay. Fe2O3, solve natin. Molar mass niya. Fe2O3. So that would be 159,687. Cancel yung grams. Okay. So you have moles. Okay, so for the mole of aluminum, makopyahin lahat ng digits. You will have 4.595656,364 mole aluminum. Okay. Fe2O3, that would be 601. Well, this will be 3, 7, 6, 3, 6, 1, 2, 5, 67 mole ng Fe2O3. Okay? Saan yung ating mole ng reactants na? Malalaman na ba natin yung limiting and excess reagent dyan? Hindi. Wala pa tayo. Nasa first part pa lang tayo ng calculation. Now we have the mole of reactant. We want to convert them into mole ng product. Convert natin siya into mole ng product. Okay. So, ito na. Dalawa yung ating reactant. So, dalawang beses tayo mag-solve ng products. No? So, we have to get the mole of aluminum oxide from aluminum and the mole of aluminum oxide from iron oxide, iron 3 oxide. Okay? So, paano isa-solve yan? So, katulad lang ng ginawa natin kanina, no? So, given ka ng mole ng aluminum, convert mo yan into mole ng aluminum oxide. Okay. So, yung aluminum oxide, tingnan natin yung balance equation. 1 yung coefficient for aluminum, 2 yung coefficient na. So, solve natin yan. Kakancel mo na yung aluminum. Solve natin yung mole ng aluminum oxide from aluminum na. So, that's mole of aluminum. Ito yon. Yan. Yan yung ipa-plug in nyo. Times the conversion factor, 1/2. So, we will have 2.297828,182 mole of Al2O3 from aluminum. So, ito yung mole ng product from aluminum. Okay? Ngayon, alamin naman natin yung mole ng product from the iron 3 oxide. No? So, kunin natin yung mole Fe2O3 times the conversion factor. Okay, so alamin natin coefficients. So, for aluminum oxide, 1 yan. Fe2O3, 1 din. Okay? So, basically, that is this number, 3.7 something. That number times 1 over 1. So, kakopyahin ko na lang yan. Times 1 lang yan eh. Magka-cancel yung Fe2O3. Okay. With that, hinto na muna tayo dito. Malalaman na ba natin yung limiting reagent? Yes, pwede na natin malaman yung limiting reagent at yung excess reagent. Ano uling idea for limiting reagent? So, the limiting reagent will always give the least amount of product. So, that means aluminum yun. This will be our limiting reagent now. That means Fe2O3 will be our excess reagent. Okay? So, ganun. Kasi, tignan mo, 2 moles lang yung na-produce. 2 point something moles lang yung na-produce ng aluminum na product. Si iron 3 oxide, 3 something moles, 3.7 moles yung na-produce niya. So, medyo marami. So, ito yung pinaka-onte. So, that means aluminum is the limiting reagent. Iron 3 oxide is the excess reagent. Okay. Para sagutin yung tanong, calculate the mass in grams of aluminum oxide formed. Sino yung gagamitin natin sa dalawa? Ito or ito? Siyempre, yung sa limiting reagent, So, to solve for the theoretical yield, theoretical amount of product formed, use the limiting reagent, Gamitin mo yung dami ng product na magagawa ng limiting reagent, So, yan. So, convert na natin yan into mass, So, we have mass of aluminum oxide that will be equal to mass times the molar mass, mole pala, sorry. Mole aluminum oxide times the molar mass ng aluminum oxide. May space pa ba? Marami pa. Sakto lang. So, yan, mole ng aluminum oxide. Kopyahin ko yung buong digits. 2,297,828,182 mole times molar mass ng aluminum oxide. Teka lang, Al2O3. That's 101,961 grams per mole. Okay. Cancel. And that will give you 2 decimal places na. Final answer na tayo eh. Okay, so that's 234.29 grams ang mapoproduce can be formed. Okay, so yan, tapos na tayo. Haba ng solution. Yes, ganyan talaga yan. So, ganon talaga. Ang kailangan lang natin gawin is that from the amount of your reactants, alamin mo kung gaano karaming products yung pwede nila magawa. The products na onte, yung pinaka-onting product na mapoproduce, yun yung limiting reagent mo. That will give you an idea. Sino yung substance, sino yung reactant na limiting. So, yung pinaka-onte yung magbibigay. So, yung sumobra, edi excess, no? Para malaman mo kung gaano karami yung mapoproduce niya, yung theoretical yield, gamitin mo yung binigay ng limiting reagent, no? Ito yung gagamitin, hindi ito. Okay? Yan, so that's the mole of aluminum oxide times the molar mass aluminum oxide. So, 234.29 grams lang yung mapoproduce na. Yun yung sagot sa letter A. Letter B. How much excess reagent is left at the end of reaction? Gano daw karami yung sobra sa excess reagent? Gano karami yung matitira? No? So, ganito lang yan. Isipin natin yan as this one. No? Ay, teka lang. Burong ko to. Taas ko lang. Yan. Think of the next question as this. No? Gano karami yung sobra? Gano karami after the reaction? So, para malaman natin yung sobrang excess reagent, no?
Or unused.
Excess reagent. No? So, yan yung unused reagent natin, unused excess reagent. Para masolve yan, that is the amount of excess reagent given minus the amount of excess reagent used. No? Pwedeng wag na unused, ang daming used left. Okay? So, kailangan alamin natin kung gaano karami talaga dapat yung magamit na excess reagent. Gaano ba dapat karami? Kasi sobra di ba? Okay, so yung amount of ER given, nasa problem yan, 601 grams, no? So, ang question natin is, paano natin makukuha itong amount of excess reagent used, no? Madali lang yan, stoichiometry na naman yan, no? So, ganito lang ginagawa dyan. You begin with this mole of product. No? So, to solve for the amount of excess reagent, paano lang yan? Used. So, anong gagawin mo dyan? Kunin mo yung mole product from limiting reagent. Kasi hanggang doon lang yung pwede, di ba? Hanggang doon lang yung reaction. So, ito yung kukunin natin. Kunin mo yung amount ng product na kaya i-produce. Hanggang dyan lang. Kaya, kukunin mo yung mole ng product from the limiting reagent. Tapos, i-convert mo yon, no? Mole product papunta sa mole ng excess reagent, no? So, ganun. Tapos, syempre, magiging mole na yan ng excess reagent. I-multiply mo yan sa molar mass ng excess reagent para makuha mo yung mass, no? Okay, so ganun lang. So, anong ginawa natin? Kunin mo yung mole ng product na ma-produce lang from the limiting reagent. In this case, that is 2.29 something. Lalagay mo yan dito. Tapos, i-convert mo yon into mole of the excess reagent. So, yan, magkagamit ka ng conversion factor. So, go-convert mo siya from the mole of your product, which is aluminum oxide, to the mole of your excess reagent, which is iron 3 oxide. So, by converting that, makukuha mo yung mole. Ngayon, kailangan mo siya i-multiply sa molar mass. Bakit? Grams yung gusto natin. Okay? Kasi hahanapin natin gano'ng karami yung sumobra, no? So, i-multiply mo yan sa molar mass ng excess reagent mo. In our case, iron 3 oxide, no? So, solve natin yan. Mass of ER used. So, that will be the mole of product from the limiting reagent. So, copyain ko lang. 2.2978 to 182 mole aluminum oxide. Okay. So, convert natin yan into moles of your excess reagent na. Fe2O3 Al2O3. 1 and 1 lang yung coefficients nila, di ba? Yeah, 1 and 1 lang. Times the molar mass of excess reagent or yung iron 3 oxide. Ay, nasolve na natin yung dito. 159, 987. 687. Okay, so ganun lang gagawin mo. So identify the mole of the product from your limiting reagent times the conversion factor from the product to the reactant na sobra, the excess reagent, times the molar mass of that excess reagent na. So para makuha mo yung grams ng excess reagent na nagamit, no? So magka-cancel yung aluminum oxide, you will be left with Fe2O3, no? Magka-cancel yung moles, matitira ay grams. Okay, so ngayon malalaman na natin kung gaano karami yung nagamit sa reaction. Solve ko. In 2 decimal places, 366.93 grams of Fe2O3 is only used. So, 366 grams lang pala yung kailangan. Sobra tayo ng marami, no? 600 meron tayo eh. Tapos 300 lang pala doon yung magagamit, no? So, ngayon, para malaman natin yung left, yung natira, that will be the minus the used amount, no? So, that's 601 minus 366.93 grams. So, ilan yung natira? 601 ba? Yeah, 601. 601, 366.93. So, that's 234.07 grams of Fe2O3 is left. So, yan yung natira. Yan yung sumobra. Yan yung natira na. So, ganun lang. So, basically, umiikot-ikot lang tayo sa concept ng conversion factors, no? Mapapansin ninyo. Since then, nagko-conversion factor talaga tayo, no? Ganun talaga ang chemistry. Puro conversion lang. Okay? So, yan. I will give you a screenshot kung paano to sinagutan, no? Popost ko to after this recording. But anyway, sagarin ko na, no? Kasi patapos na tayo, eh, no? Ang natitira na lang na topic ay reaction yield, no? So, discuss ko na to para sa Saturday wala tayong gagawin. Panoorin nyo na lang yung video kung may internet na kayo kasi may bagyo eh. Baka mahina signal nyo. Kaya hindi kayo nakaka-attend. That's just okay lang, no? So anyway, so let's proceed with the reaction yield, no? So what is a reaction yield, no? A reaction yield is the percentage of the amount of the actual product, no? Yung dami ng product na maproduce mo from the theoretical, no? Ibig sabihin, yung mismong dami ng product na magagawa mo ay onti pa pala sa theoretical, no? Kasi yung theoretical, that is based on assumption na perfect ang reaction. Okay, yun yung best product, yun yung best amount ng product na mapoproduce natin, yung theoretical yield. At that assumes na lahat talaga ay magagamit, no, in producing the product. However, that's not the case always. Hindi ganun yung case. Bakit? Kasi there are several factors that affect the reaction yield, no? For example, kunwari, marumi pala yung tubig na nagamit mo, marumi yung chemical na nagamit mo. So, that will decrease your yield, no? Onti lang yung mapoproduce mo talaga from the theoretical amount, no? So, bababa yung amount na napoproduce mo talaga. Kunwari, during the reaction, binuksan ng friend mo yung yung reaction vessel, yung container. Tapos nag-escape yung ibang gases. So, bababa yung yield mo. So, kumbaga, the reaction yield tells you the ratio ng actual amount, no? Yung mismong na-produce from the reaction, yung mismong amount ng na-produce sa reaction compared to the theoretical, yung based on the calculation. And usually, given naman yung given naman yung actual amount ng product na mapoproduce mo, no? Okay? So, this is still combination of, limiting and excess reagent, mass-mole relationship, stoichiometry, no? So, kumbaga nadadagdagan lang tayo ng additional steps, no? Sige. So, sasagot lang ako ng isang item. Ito na lang. O, kunwari ito. Industrially, vanadium metal which is used in steel alloys can be obtained by reacting vanadium 5 oxide with calcium at high temperatures. Given the reaction, 5 moles of calcium reacting with vanadium 5 oxide, producing 5 moles of calcium oxide and 2 moles of vanadium metal. In one process, 1.54 times 10 raised to 3 grams of vanadium 5 oxide reacts with 1.96 times 10 raised to 3 grams of calcium. Calculate the theoretical yield. So, kanina pa natin ito ginagawa. So, mauumay ulit tayo sa solving. Sige. So, we are given two amounts of the reactants, no? We have to convert them into the mole of the product. In this case, vanadium. So, kailangan alamin natin yung moles ng, yung amount ng vanadium na maproproduce out of the two reagents, no? So, scheme, way ng solving. So, you have the mass of your vanadium oxide. I-convert mo yan to mole ng vanadium oxide. Then, to mole ng vanadium. Then, to mass ng vanadium. Okay, so yan yung scheme natin. So, you have the mass of your reagents. You don't know kung sino yung limiting and excess dyan. I-convert mo sila to moles. Then, yung moles ng reagents mo, i-convert mo to mole of your product. Dito mo malalaman kung sino yung limiting at sino yung excess. No? Then, you can solve for the theoretical yield. No? Sige, gawin natin yan. Medyo maraming solving. Yes, wala tayong magagawa doon. So, convert natin yung mass ng reagents to mole. No? Mole V2O5 and mole calcium. So, that's mass ng V2O5. Molar mass V2O5. That is mass calcium over molar mass ng calcium. (154 times 10 raised to 3 grams B2O5 tapos 196. By the way, na ako dito, magsa-scientific notation na ako. Unless mababa lang yung digits, I don't know. Tignan natin yung mangyayari. Feel ko kasi kailangan ko mag-ground off eh. Kunin ko yung molar mass ng B2O5. B2O5. So that's 181.879 grams per mole. Okay. So calcium naman ay 40.078. So kunin natin yung mole nila. No? This time kailangan ko mag-round off kasi ang dami na eh. 1 kilo eh. So mag-round off na lang ako. Hindi naman pala ganun karami. Sige, kopyahin ko na lahat. Kopyahin ko na lahat. So, 8.4671677 32 mole V2O5. So, yan yung mole ng V2O5 natin. Calcium naman. Dami 48, 90, 46, 35, 96 mole calcium. Okay? So, ayan. Nakuha na natin yung moles. Ngayon, i-convert na natin sila to mole ng vanadium. From V2O5, mole vanadium from Ca. So, you begin with mole V2O5. Convert mo yan into mole ng vanadium. So, mole V2O5, vanadium. Tingin ka sa equation, anong coefficients? This is 1, this is 2. Ganun din sa calcium, no? Paulit-ulit lang talaga yung gagawin natin dito. This is 2, this is 5. Okay? Solve na natin. Yung gagawin natin, plug in natin ito sa V2O5. Plug in yan dyan. Tapos plug in ito dito sa mole ng calcium. So you can see, V2O5 will cancel out. Calcium will also cancel out, no? Giving us vanadium. No? So that will be V2O5 muna ako. This will be 16, 9, 3, 4, 3, 3, 546 mole vanadium from V2O5. Okay. O calcium naman, daming numbers. 40, 90, 46, 35, 96 times 2/5. Okay. So that's 9.56185438 mole vanadium from calcium. Ito yung amounts ng products from our reagents. Can we now identify sino yung limiting, sino yung excess? Yes, no? So, sino yung pinakaunting product na na-produce? Itong galing sa V2O5. So, this is our limiting reagent. This is our excess. No? So, the theoretical yield of vanadium So, to get the theoretical yield of the vanadium, ang gagawin mo na lang is to convert this mole into mass of vanadium, no? So, gagamitin always yung sa limiting reagent, no? Gaya ng sinasabi ko kanina pa, no? So, gamitin ng kay limiting reagent, i-convert yung mole to mass. So, that's mole V from limiting reagent times the molar mass ng vanadium. Dito na sa baba. 16, 9343, 3546. Ano yung molar mass ng vanadium? 50, oops. 942 grams per mole. Ang theoretical yield natin ay, teka lang, daming numbers. 50, 942. 862.6667 na. Okay, so ito na yung theoretical yield, no? So, yan lang yung kaya ma-produce ng reaction na. Okay, so that's how you solve for the theoretical yield, no? Paulit-ulit lang ginagawa natin, no? Ngayon, punta tayo sa percent yield. Calculate the percent yield if 803 grams of vanadium are obtained. Kunwari, yan lang daw yung na-produce, no? So, ano yung theoretical yield natin? Theoretical yield is 862.67 grams vanadium. Ano yung actual yield natin? Yung mismong na-produce, no? Sabi sa problem, 803 grams vanadium. So, ganyan lang daw karami na-produce. Ngayon, paano sinasolve yung theoretical yield, no? So, to solve for theoretical yield, the percent yield rather, so the percent yield is the ratio of the actual yield over the theoretical yield times 100%, no? Or times 100. Okay, so ganun lang gagawin natin. So the percent yield is equal to the actual yield, 803, divided by the theoretical yield, which is 862.67 times 100. So the percent yield would be, ano? So ganun lang gagawin, no? Divide mo lang yung actual sa theoretical times 100. Just 803 divided by 862.67 times 100. So the percent yield is 93.08%. So that is our final answer. Okay. So yan yung ating mga kasagutan sa problems dito na. So ganun lang. Paulit-ulit lang to na conversion ng mass to mole, mole of given to the mole of desired, no? So yun, basically ang ginagawa lang natin ay synthesis ng lahat ng methods ng solving natin, no? So ganun na. Kung mapapansin niyo, mass mole conversion ginagawa pa rin natin until now. Ang nadagdag lang today ay itong stoichiometry, no? The conversion of 1 mole of a substance to another mole of a substance, no? So yan, kailangan may balance equation ka lang. And alam nyo na naman kung paano mag-balance ng equation, no? Pag nakalimutan, balikan nyo ulit itong video na to. Okay? So that ends the chapter 6, no? So sa Saturday, wala tayong gagawin. Pahinga muna. Sa Wednesday, tayo ay magkakaroon ng next week, no? Chapter 7 na ano. That will be the last chapter. Then magkakaroon na kayo ng ano tawag doon? Second prelims nyo. Okay? So yun. Ayun lang. So I'll see you again next week, no? So wala tayong meeting sa Sabado. So send ko na lang yung mga answers dito sa GC, tas yung link sa YouTube, no? And yun. So stay safe, and if you have any questions, ask me lang, no? So yun, i-open ko na rin yung quiz dito siguro sa Sabado na lang, no? Para may time kayo manood, no? So that's good for 1 week as well, no? So yan. So I'll see you again next week, and bye-bye.